Hello, this is Kwang Hak for this ray tracer reflection multi-teapot assignment. Our team implemented a shadow test using a shadow ray to determine if an intersection point is blocked from the light source. And second, added an offset to the shadow ray origin to avoid self-shadowing due to floating point precision issue. And third, we modified color calculation so that object in shadow appears darker. And let me show you the result we got from the code. And this is the result. And as you can see, compared to the original image, this is what we got from the modified code. It has much more shadow and darker color for contrast. Now let's go over the code. And this is the code from the text, from the textbook. So let me go to the code we have made changed. Okay, so this is the shadow calculation, and this defines the light source position. So this setup the position of a point light source at 0, 5, and 0, meaning the light is located 5 units above the teapot. And this calculates direction from intersection point to the light source, which means compute the light vector pointing from the surface intersection point to the light source by subtracting the intersection point from the light position. And this compute the distance to the light. So finds the Euclidean distance between the intersection point and the light source. And lastly, we normalize, this code normalize the light direction vector, so converts the direction vector to the unit vector, keeping only the direction while ignoring the magnitude. And those are the codes that one of my group members wrote it. And this is the offset origin to avoid self-intersection. So we have the ray called shadow ray is created. This starting from the slightly offset intersection point and moving towards the light source. And we initialize the shadow flag. This flag determines if the point is the shadow or not. And for this for loop, check for intersection between the shadow ray and other object. Iterates through all the faces in the scene and tests if the shadow ray intersects any object using the intersect ray triangle function. And here, determine if the intersection is a shadow obstruction. If the shadow ray hits an object before reaching the light, the intersection point is in shadow. And is in shadow, set it to true. So, and the break statement exit the loop early if an intersection is found. And here it adjusts the pixel color based on the shadow status. Mm, If If the point is in shadow, the reflect color is darkened to 50% of its original intensity. But if the point is not in shadow, the color is blended with the white color for normal illumination. And uh, and this codes return the final computed color to this is just the background color, which is dark. Yeah, I think this is it for our ray tracer reflection multi-teapot assignment. Thank you for listening.